So let's just summarize what we got from that last problem. All right, so for the first two parts, the big question was trying to figure out is the light converging too far or too close? And one way you could do it is just say, this camera is having a problem like farsightedness, so it's converging too far. But you could also say, the problem is when the object is too close. Well, if the object is too close, that means the light is not converging very much outside of the lens. That means that it might not converge soon enough inside of the lens. You didn't have any trouble with part B. Part C was tricky. Notice again, if I had a choice, I would try to avoid ray tracing for multiple lenses. In fact, even in his answer, he's not doing any real ray tracing for multiple lenses. That's too complicated. And I'm even going to avoid trying to do a bunch of algebra here with numbers, because he's just asking for a qualitative answer. So the key thing here is, I actually made a picture of where object 1 is. And this is the key thing, to read carefully and see the whole purpose of the lens. So this is really like the eye again. It's really like the eye. This is supposed to correct the camera. Well, when you're correcting the camera or the object, where do you want to put? So you want to put the object where you want to be able to see it clearly. So we put the object where you want to be able to see it clearly. And then where should the image be from the corrective lens?
At its actual near point.
Yeah, at the actual near point for nearsightedness. For farsightedness of the camera, because then it can take it from there. Now, if there was a distance between these two things, then the distance, just because you're 60 centimeters from one wouldn't mean you're 60 centimeters from the other. That's a complication, but this is like a contact lens. It's right on top, so we don't need to worry about that. But basically, you want to put the image from the corrective lens at the near or the far point for the defective eye, because then that will allow the lens of the camera to put its image on the film over there. That was the most important problem-solving technique. And then we also went through the idea that corrective lenses make virtual images. That helped us to find the right part of the chart. And even if we weren't using the chart, that's what told us this was negative, that it was a virtual image. So that was important for doing the algebra. Okay.
If it wasn't a contact lens, then how would that affect it?
So,
if it was glasses?
Let's say that this lens, corrective lens, is like glasses. So here's the corrective lens. Now, we still want to be able to see an object that's 30 centimeters from the camera. We still want to be able to see an object that's 30 centimeters from the camera. And we know that the camera has a near point that's 60 centimeters from the camera. But now there's a distance between the corrective lens and the camera lens. You might say that there's a 3 centimeter difference between these. That actually would not have any impact on this problem because we just did it qualitatively. But if we were actually going to plug in a number now, what number, so this is the lens mirror equation for the corrective lens. What number would we plug in for S for the corrective lens?
S is where you want to see the object.
Take your time. Oh yeah, okay, I guess that's right. Okay, so what would we plug in for S?
So it'd be 3 plus the distance.
Point to S in your picture. S is from where to where?
S is from here to the object.
Oh, okay, good. Oh, I think the problem is that you've mislabeled your 30. Remember that 30 centimeters represents, we want to be able to see an object that's 30 centimeters from the camera. We're not trying to see an object that's 30 centimeters from the corrective lens. We want to be able to see an object that's 30 centimeters from the camera. So the problem with your picture is you've got the 30 centimeters ending over here. We should have the 30 centimeters ending here because they told us that they want to be able to see an object 30 centimeters from the camera. So we put this 30 over here.
So would the S be 27?
Yeah, now we've got it. Then it would be 27 because S represents the distance between the object and the corrective lens because this is the corrective lens equation. So that would be this distance of 27. It's really crucial here to draw the beginning and the ending of each distance. People have a very bad habit of just using a hash mark to indicate the distance, but then that doesn't tell us the distance from where. Instead, we have to use arrows or hashes, double hashes, that show from where to where. So then this number over here would be positive 27, and how about the image distance?
So that would be 57.
Like this?
Yeah. If it's
That's good.
60 centimeters.
Now, the key thing is just to see it from the picture, right? You can see right from the picture here that this distance is 57, right? Because this total distance is 60, and we subtract the 3 to get the 57. So what would I write for S prime?
Minus 57.
That's what I was getting. Okay. We again should feel very uncomfortable if we don't put in the sign. This is where everyone loses it on this type of problem. Forgetting to put in the sign, corrective lenses make virtual images, so you can never see too much repetition of that. So yeah, the big traps here are, first of all, forgetting the sign, and also just plugging the numbers you're originally given, even though they're not the distances from the corrective lens. We need the distances from the corrective lens. So it's important to draw a very clear picture that clearly shows where each of the distances start and stop to avoid that type of trap. Okay.
Thank you.
Thank you. These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There is a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm, or you can just use the link in the info box. By the way, I also offer tutoring via Skype, and you can find more information about that Skype tutoring service at my website. Thanks.